Okay, so let's look at a hyperbolic paraboloid. Hyperbolic paraboloid. This is on page 895 in the book. So they've got, basically it's like a horse saddle is kind of what that looks like. But they've got something that looks like this: y squared over b squared minus x squared over a squared, which we could have flipped that and just had the minus on the x squared term, right? But then that equals z over c is kind of how they're doing this. So we do not have a z squared. So that's what's different about this one. So what can we do? Well, if we have z equals 0, then what do we get? Then we get y squared over b squared equals x squared over a squared. You know, if I take the square root of both sides, then you know, basically I get y over b equals plus or minus x over a. And it's not it again. So not sure what's going plus or minus. Let me clear the board. See if it lets me write. Hey, it's let me write. Okay. Clear the annotation. So instead of continuing with that awkwardness, let's just look at a specific one and kind of talk through what it looks like. So this is actually example 7 in the book, but 3y squared minus 12z squared equals 16x. Notice that it really doesn't matter which one. Two of them are squared. There's a minus sign in there with the squareds, and then there's a single variable on the other side. So we're kind of looking for that pattern. So the reality is I could divide everything through by the least common denominator, right? Which what would that be? 12 and 16, 48 works for that. And then, yeah, 48 works for all of them. So I could divide both sides by 48. And if I do that, divide each part by 48, this becomes y squared over 16 minus z squared over 4 equals x over 3, right? And then, of course, I could write that as 4 squared. I could write this as 2 squared. I do not need to rewrite this one because that's just an x, not a squared. Okay, so don't worry about that. But anyway, so the reality is, what do I have here? Well, let me just erase, give myself some room here. And so I'm just going to rewrite that, hopefully. Y squared over 16 minus z squared over 4 equals x over 3. Okay, so the reality is, first of all, if I let x equal 0, so I'm going to try and use different colors here. So if I let x equal 0, then what I have is I have y squared over 16 equals z squared over 4. Take the square root of both sides, and I'll get y over 4 equals plus or minus, because I took the square root, z over 2. And then I can multiply both sides by 4, and I get y equals plus or minus 2z. Now, what's that? That's a line. And of course, that's when x equals 0. This is a cross section. And so, once again, on a cross section, when x is 0, I'm on the YZ plane. Okay, so I'm on the YZ plane, and I get that y equals plus or minus 2z. I'm gonna kind of keep showing the YZ plane. So y equals plus or minus 2z. What's that like? If this is like my x-axis and this is like my y-axis, this is kind of like x equals plus or minus 2y. And if I solve that for y to be the up value, then plus or minus 1/2 x. Y equals plus or minus 1/2 x. Well, y equals x, you know, if this was once again, if this was like my x-axis, this is like my y-axis, then I can look at this. But anyway, y equals, I'm going to switch my colors. Y equals x splits right in the middle. So y equals 1/2 x goes up half as fast. And once again, this is just on the table surface. So this is actually the equation y equals 2z. And this is the equation, it's less than, here's a 45-degree angle, it's less than that. And this should be y equals minus 2z. Should be these. So this is kind of one thing that the graph follows, and then that's when x equals 0. Well, let's look at something different. What if z, and I'm going to let z equal 0 here. So if z equals 0, then we got y squared over 16 equals x over 3. Okay, and then so basically, what does this become? So x multiplied by 3, I've got x equals 3y squared over 16. That's a parabola. So when z equals 0, I have a parabola. And I know I'm getting crowded here. I may have to erase. But a parabola, so z equals 0, means I'm on the table surface, right? So I'm going to bring the x-axis out. Remember that that purple x that you say, that flat kind of flattened x, is just on the table or on the board surface, right? And then now z equals 0, I'm on the table surface, and that's a parabola once again. So x equals 3y squared. So usually we have y equals x squared goes up the y-axis. So this is going to actually come out at us. And instead of getting specific, oops, I need blue. Instead of getting specific values, I'm just gonna do this. So this is a parabola coming out this way only, but it does touch the origin because 0, 0 is on the graph. But if you wanted to, and you said, hey, if y is 1, or no, well, let's say y equals 2. If y equals 2, no, 4. If y equals 4, 4 squared is 16, that canceled, we get x equals 3. So basically I'm over 4, out 3 is on my graph. And then if y is left 4, I'm still out 3 on my graph here for my parabola. So you can get accurate on that if you like. So that's a parabola, and you know, basically that will continue for a while. But let's look at one more. So I'm gonna try and, okay, so I'm warning bell on this one. I'm gonna erase this, I think, on the right, give myself some room. And if I go, if I let now y equals 0, the question is, what do I have? So let me go back and draw. If I say y equals 0, then I have minus z squared over 4 equals x over 3. And this is trying to see what the easiest way to do this one is. Y equals k's parabola. Let's see. So this is a parabola that opens down, right? So if I multiply, so that's x equals minus 3/4 z squared. So once again, this is a parabola, but because this is negative, it flips, right? So instead of, once again, if this is y equals x squared is up, so this is like, it would be up the y axis, so this will be up the z axis, but instead of going up, it actually goes down. So I'm trying to see which way. This is on the table surface. So vertically, instead of coming out, so if we have y, I got to go back to 2 dimensions. So I'm going to try and talk you through how I think of this. Oh, I got to change my colors. So if I have y equals x squared, it looks like this, right? So the y, it's up, it's a parabola around the y-axis. So here I have an x, so it's a parabola around the x-axis, which normally would be out this way, but then it's a negative, so it goes down. So if it's minus x squared, it goes down. So in this case, it's going to go behind. And so I got to change this to green. So I've got a parabola back here that goes this way. Okay. And then long story short, we've got the things that we follow there. And so it ends up making a saddle, but any cross section is going to be like that. It comes back, touches that, cross section like that, touches that. Anyway, it kind of makes a saddle through there, and kind of hard for me to draw this saddle, but you know, you sit on the saddle on the positive side of the x-axis. So once again, figure 23 is the one that you want to look at for this. All right, so that is a better version of that. This is really annoying having her talk, but during my class. Anyway, so I'm through page 897. I will try later on. I have to do some other things now, but I'm going to try to do like an elliptic cone, otherwise read through that, but maybe I could just say elliptic cone, x squared over a squared plus y squared over b squared minus z squared over c squared. And I know what you're thinking, like, hey, I know what that is. That's a that would be like what we did before with the elliptic hyperboloid of either 1 or 2 sheets, right? But that's if it equals plus or minus 1. So I think I'm just going to finish this here. I'm going to just keep rolling with the recording because I don't think this will take long. Equals 0. So now we equal 0 here. What do we notice? We've got one of these with a minus sign, but now this equals 0. So what I can do then is basically I can just add that to both sides, and I get x squared over a squared plus y squared over b squared equals z squared over c squared. And anyway, so now I can say things like, hey, if I let y equals 0, what do you get? You get x squared over a squared equals z squared over c squared. And then, of course, taking the square root of both sides, we get x over a equals plus or minus z over c. Well, this is just a line, plus or minus on that line. And so, long story short, when y equals 0, then we get a line. So that's coming, here's the z and the x, and then we get a line that's both, you know, positive and then negative. This is through the screen there because y is 0. This was the x-axis coming out, and that's the z-axis up. X and z. So maybe let me just look at a specific one, talk you through that, and just try and finish this up. Okay, so let's just look at example 8, just so I can go super quick. 4x squared minus y squared plus 25z squared equals 0. I've only got a few minutes left on this too. I might get cut off. Anyway, divide everything by at least by 100 on both sides, and we'll get anyway, x squared over 25 minus y squared over 100 plus z squared over 4 equals 0. So once again, this is going to be a cone, double cone, elliptic cone, and instead of the minus sign being on the z term, the y term, so long story short, my cones are going to go along the y-axis like that, just so you know. So anyway, there's the y-axis out to the right. There's the z-axis up top. There's the x-axis out there. But anyway, so we're gonna get a couple different lines here. So let me just clear this quick. Let me go back, and so we kind of know where the cone is heading out, and so I'm going to go ahead and put the negative y-axis on there too, so my cone can follow that. But if I do, let's let so what was our equation? Let me just rewrite that. We had x squared over 5 squared, 25, minus y squared over 100, which was 10 squared, and then plus z squared over 4 is 2 squared, and that equals 0. Notice the difference between my z and my 2 is the minus, the slash through it. But anyway, it's going to follow along the y squared there, or the y-axis, because that's where the minus is. But anyway, so let's let y equals 0. If I let y equals 0, then I get x squared over 25 equals, plus z squared over 2 squared, or 4, equals 0. And so anyway, so if I've got that, the only way this is ever going to work is if x and z equals 0. Okay, so basically that gives me the origin. So now let's do something else. Let's let x equals 0. If x equals 0, then I've got minus y squared over 100 plus z squared over 4. So, or in other words, z squared over 4 equals y squared over 100. And then I can take the square root of both sides, and I get z equals, multiply by 4 on both sides first, and then that's going to end up being y squared over 25. Anyway, z equals plus or minus y over 5. Okay, 1/5 y. So anyway, that gives us an equation. So if we had y equals 1/5 x, it's kind of flat like that toward the x-axis. So this is toward the y-axis along the z. So it's this would be z equals y over 5. And then, of course, I have z equals minus y over 5 for this one. So those are two lines that are along the board surface there. Anyway, and then what I could do, like if I have any other slide, we knew it was going to go along the y-axis. Well, what if we had y equals 10, okay? And then if y equals 10, this is 1, right? We can add 1 to both sides, and we get x squared over 5 squared plus z squared over 2 squared equals 1. Well, what's that? That's an ellipse, right? That's an ellipse. So for y equals 10, which is out here, I get an ellipse, right? And for y equals minus 10, I would get an ellipse as well. And so notice that my elliptical cone, both of them are running along the y-axis on the positive and negative side. And then I could do one more here. So I let y be 0. I let x be 0. I did not let z be 0. And if z equals 0, what do we get? We get x squared over 5 squared, x squared over 25, minus y squared over 100, so equals y squared over 100. I'm going to multiply both sides by 100, and I get 4x squared equals y squared. Take the square root of both sides, and I'll get y equals plus or minus 2x. And So y equals plus or minus 2x. It's a little bit, it's coming out, but it's the x and y, because z equals 0, so I'm on the xy plane, which comes on the table surface. But anyway, it ends up coming out and then back, and then from the top part here, coming out through the origin and then going back. Anyway, long story short, we end up with a beautiful picture that looks exactly like figure 24. And I am done. And then they have a great summary on page 899. So you guys have done 900 pages of calculus, but knowing the general shapes based on the formula, try and make the formula look like it. Hopefully today's class allows you to recognize what the shape should look like and maybe which direction it points. So I'll let you figure out which direction it points on the saddle surface.